In the recent years, the consumption of poultry meat has risen considerably, surpassing the overall consumption of beef and pork in several countries. Poultry farming has been a target of criticism when it comes to the conditions with which the animals are treated, as well as the often poor quality of the work environment the workers are put through, and lack of versatility when tending to the large number of animals that need specific care. To help innovate in this current scenario, Chicken.io is a system developed to automate functions in a chicken coop. The system is composed of two separate stations, the feeder and the nest. At first, instead of any of the traditional feeding procedures, Chicken.io introduces a way to customize the food each individual chicken will receive by identifying the animals through RFID tags. The system also records data about the environment and the animals themselves, such as their weight and the temperature, humidity, and luminosity of the coop. Additionally, Chicken.io also allows for the recognition of the number of eggs laid by a specific chicken, as well as their corresponding weight. To achieve its goals, the system is composed mainly of an embedded system, a cloud server, and a web application. The embedded system is centered around a Raspberry Pi, which controls all its functionalities. These include the RFID readers, environmental sensors, load cells, and the relay which controls the food dispenser motor. The cloud server is implemented using the Node.js framework, Postgres relational database system, and the Heroku platform as a service for deploying the application. This server is the heart of where all the data will be kept, making the connection between the embedded system and the web application. Implemented using the Vue.js framework, here is where the user will effectively browse their data, customizing the care for their animals and monitoring their behavior. The project was developed over the course of 9 weeks, including project planning, independent implementation of each of the system's features, followed by the overall integration, and finally, testing. Using Chicken.io starts with logging into the system. A chicken can be registered by filling up its data, such as how often should it eat each day, how much food should be dispensed per meal, and how many hours should be given in between meals. Let's call our chicken Molly. When approaching the mechanical structure, a chicken will be identified and conditioned through LED lighting on whether it can or cannot eat at the moment. The relay will activate the food dispenser and will deactivate when the correct amount of food is weighed by the system for the specific chicken currently on the perch. Molly can then start eating, and when the system recognizes the food is no longer in the bowl, it will condition her to leave and allow her friends to eat as well. Finally, when there comes a time for a chicken to lay eggs, it will approach the nest and be once again identified by the system. The egg Molly lays will be directed downwards via a smooth slope and deposited on the weighing basket. All this data is constantly being sent to the server, as well as the environmental data, which is periodically measured. Coming back to the web application, the data can be displayed in intuitive graphs, allowing the user to spot any relevant information about the health and well-being of their animals, including Molly, who we want well-fed and in good conditions to continue laying eggs safely. With Chicken.io, you don't just tend to your chickens, you care for them.